In this video, we have a word problem where a boat is traveling en route, and we want to find the distance of the boat from this buoy at some certain time t. The boat is traveling due east. It passes 200 feet south of a buoy. Let's stop right there and just draw what is happening. So I've got a buoy here floating in the water, and it's got a little flag on it, and the boat passes 200 feet south of that. So here's the boat, and it's going that way, due east. This is 200 feet. Okay, now the boat travels another 1,000 feet. So let's draw that. It's going 1,000 feet right there. I'll put a 1,000 there. And then it changes. It turns due south and travels at a constant rate of 20 feet per second. So we'll go like that. And I'm just going to put an arrow. 20 feet per second. So we'll put its distance as 20 times t, where t is the number of seconds that have elapsed since the time that it has turned here. So, how do we find the distance between the buoy and the boat t seconds after the boat has changed course? This is a great big triangle. So, I'll just draw that there. It's going to be like this. And let's go through here, and I'm going to hash mark this part of it, because this part that I just hash marked, that is changing. This is the 20t. The 1,000 part of the triangle is always the same. So let's draw the last part of that triangle, and that is right here. Let's put another color that you can see that a little bit better. And this is the distance that you need to know. Well, the distance equals this 200 feet, this leg. I'll label that A. That's 200 plus the 20t. And this distance is always going to be the same. That's 1,000. Okay, well, distance equals the square root of the, I'll label this B here, of A squared plus B squared. That's a distance formula between 2 points. So it's the distance, it's the square root of A squared plus B squared. Okay, now that we have that, let's just go ahead and plug this stuff in. So the distance equals, well, A, instead of A, I have 200 plus our 20t. That's this part here. That's our 20t, because that is what is changing. That is squared, and then plus the 1,000 squared. I'm just going to write 1,000 squared. That is 1 million, but I'll just write 1,000 squared to save a little space there. So that's it. That is the function in terms of t. Now we could simplify this, certainly in the books, whatever book you're using, they'll probably want you to simplify it, but we can simplify this real quickly. So 200 plus 20t quantity squared, that is going to give us 40,000 leagues under the sea, plus 8,000 t plus 400 t squared. I'm running out of room here. Plus 1 million. I'm going to write that as 1,000 squared. Okay. At this point, we can factor out 400. And I'm going to factor out the square root of 400. So we have the square root of 400 times the square root of 100 plus 20t plus t squared plus 2,500, square root of all of that, and the square root of 400 now is just 20. So that's just simplifying these radicals. So I'm going to write this out. D, the distance in terms of t, this function, equals 20 times the square root of, add 100 plus 2,500, that's 2,600 plus 20t plus t squared. Now, this problem was pulled out of a book as an example. And I just want to talk real quickly. It discusses this as a composition of functions, and there's nothing wrong with that. That's a great way to do it. I like to just bypass that and just go right to the picture. The reason for that is just because I see that better. It helps me see it better. If it helps you to do it better that way, then do it that way. If you would rather do it by composition of functions, do that as well. I hope that helps.